I am a civil structural engineer, and what that means is that I get involved in the design and the in overseeing the construction of some fascinating structures that are in what we call the civil engineering world. Those tend to be things such as bridges. Over my shoulder, you'll actually kind of see a artistic rendering of the Golden Gate Bridge, a suspension bridge across the San Francisco Bay. Those are large horizontal type structures. I personally have been involved in very tall structures down in the Gulf of Mexico. So these are, although they're called shallow water, they might be structures that are 500 feet to 1,000 or even 1,500 foot deep of water. So those rival the tallest of buildings or skyscrapers that we have on the earth. So I've been involved with some very large structures. I've also been involved in your more typical, say, 20-story building, 5-story building, and of course lots of 1-story buildings, because 1-story buildings make up about 70% of the world's structures that house people. Also been involved in small little tiny gazebos and picnic shelters and that sort of thing, all kinds of interesting, fascinating types of buildings and structures, and not just bridges, and not even just those kinds of things. The structures also from the civil application involve water tanks. Not only, of course, do those tanks have to be able to contain the water, but they also have to have a structure then that supports that. Or tanks that are in some sort of water clarification system or wastewater system that is treating and handling the water. So there's this great bridge, pun intended, great bridge, civil structural engineering across all the various aspects of what we call civil engineering. And it also relates quite a bit to some of the structures that you'll see in, say, the mechanical and even electrical engineering world. So towers that support electrical transmission lines, or the types of systems that you use to construct facilities. I get involved with all that kind of stuff as well. There are various parts of mechanical systems that, as a civil structural engineer, I know a lot about, including even structural dynamics and vibrations. So that gets related to applications to, of course, airplanes, as well as a lot of other mechanical equipment. For me, actually, it relates directly to how structures respond in extreme events such as earthquakes and hurricanes and those kinds of what we call hazardous environments. I spent a lot of my career focused on how structures responded to hurricane level ocean waves, right? And understanding how those structures performed as they were at or near collapse in what we call the dynamic or the time domain, which just means, as the event is happening, what happens to those structures as things begin to have problems. Structural members start to either fail, or they go into what we call the plastic region, which is a lot like stretching something so that it then begins to plastically deform or permanently deform types of things. That's where I started off my career in, was actually looking at those kinds of collapse behaviors. So think in terms of the World Trade Center tower collapse, that's the kind of analyses that I perform. In my professional career, I've also dealt with a lot of cause and extent of damage types of investigations. So that's related, of course, to the collapse kinds of things. If you have a repair, retrofit, renovation that you're considering in a facility because you want to repurpose it, rethink about how to use it, extend its lifetime so that you're not using brand new material and the energy that goes along with having to construct brand new material. So there's that sustainability aspect there. You have to conduct an investigation to understand that, what that system can handle. All those kinds of things, that's the type of thing I was doing in my professional career, and in my teaching side of the career. Then I'm, of course, teaching some of those aspects as well, some of the core fundamentals that come along with that. So my world as a civil structural engineer is particularly been focused on what we call this broad scale of investigative engineering, or how structures fail, why did they fail, what can we do to make them better and perform better, or what can we do to reuse or repurpose a facility.